Okay. Now we finished the topic of regression and the loss function, and we talk about logistic regression and its corresponding measurement, which is cross entropy, by using cross entropy. Okay, so basically they fit two different problems. One is for numeric target, the other is for categorical target. Okay. So on the next topic, okay, take a look at our website. Okay. We would like to go over this part, which is right here, T05. Okay, topic 05. Visualize the machine learning tool, which is called Orange. So currently, we have a website right here. You can simply just Google Orange and Python. Okay, I have to stop right here because the resolution is not that good. So maybe we take a few minutes to solve these things. 不要 scaling 啊，就720啊，用720。
没有，那还是你就直接就是一把那个题目的解释就是把它降低就好了。
好啊。是啊。
对，也好啊。
720啊。对。
然后你OBS上面的那个要 fit 一下，不然它会太大。
这样？
对啊，没有，这 full screen 是。
哦，这。
transform。
Fit to screen。
对。
Scratch screen。这里要拿的，不是啊，这个是谁？
这个应该是整个 cap，
这是整个 capture。
试试把那个，或是可以就是先关掉一下重开。
这样子有没有？
对，但是这边看还是。
我知道，等一下。
或是我在想。好，
我可以先把所有的都删掉，这个我都可以删掉。这个我都可以删掉。你看，现在这一个是里面那一个，这个是外面这个。
所以刚我 double click 这个。
所以你这个，所以你说这个全这样。为什么它只把那个？
刚我是 double click 它。对，然后这个拉。
因为这个是 Chrome 的。
哦。
这个是 Chrome， 这个不重要。只有这个，现在只有这个。
对。但是它还是。
没有，我觉得应该就是继续啊。
有我 Fit to Screen 的。
没有看。
哎，也不是他。
他可能没有办法，他可能没有重做了。
手要整个关掉加重来了。
要不然我们可以放大。
哦，对，这样也可以。
就是硬把它放大嘛。对。然后看一下这个，要等一下啊。
可以接受。
但resolution不好啊。为什么？我的上传有这么低吗？现在看起来很低啊。
看一下。可以。
那你自动选自动。喂 ，OK，the resolution looks much better right now. If you are on YouTube, maybe you can check your resolution to 480 or 720 pixel. Okay, so in this hour, okay, we'd like to introduce T05, which is a visualized machine tool. Machine learning tool. It's called Orange. The reason why I introduce this one is because it is open source, it is free, and it is you can easily install it in your Python execution environment. And I think some of the basic concept is already in the process of using this tool. So I think it's quite nice to show these things, especially the data analysis workflow, okay, and some evaluation things right here, okay. So you can simply just Google it and you can find this website. And also, I strongly recommend that you go to its YouTube channel. It has about 20 very quick lesson. Okay, each lesson might be 3 minutes or 5 minutes. They introduce some concept of data analysis. Okay, so I will put the YouTube channel of this Orange tool, okay, in our website, so you can check it out. Okay, so if you want to install it, it's quite simple. Just simply so here's the documentation, and you can just simply get started. Okay, try to install it in your own laptop. Okay, so here it is. If you execute your Orange on your laptop, it looks like this. Okay, it gives you a canvas. Okay, it gives you a canvas. At the left hand side, there are several tools. Okay, including different categories. First one is data related. Okay, you can import your data, you can export your data, you can clean your data, you can manipulate your data by using the widget right here. Okay, that is the first one. And second one, here is the visualized tools. Okay, you can plot those data. Okay, if you need the x-axis, y-axis, you need the scatter. Scatter 就是散布图哈。If you need a scatter plot, you want to draw the distribution of a feature, of you want to compare the correlation between two features, just as what we did in the last week. 你要画散布图啊，distribution 就是这个分布图啊，你想画两个 feature 的correlation 就是相关系数啊哈。Okay, you can use all those tools. You don't have to write code. Okay, here is the model. As we mentioned before, there are a lot of tons of models has been invented by mathematicians, by those data scientists. Okay, So here you can see here, okay, this graph. Okay, you can just click it and drag it to the right hand side. Okay, drag it to the right hand side. Okay, the pink one are models. So as it says, it is a linear regression model. Okay, that is what we taught you last week. That is the logistic regression model. You simply just take a look at this small widget, okay, because it has several dots and it's a line, straight line, so it's just like linear regression. And here it's a Z shape, right? Just what as I show you in the previous hour. So that is a logistic regression. Okay, so you don't have to write code. You can simply just use this tool to perform linear regression, logistic regression. Of course, there are several other models, just like SVN. Okay, what we will talk about next week. Okay, and some other models. Okay, but before we introduce all those complex model, okay, we'd like to show you how to do the entire analysis. Okay, so that's the reason why we use orange to explain these things. Okay, that is evaluation, right? Evaluation. So we have a lot of model. Which model is the best one? As we mentioned before, we have MSE to evaluate different different linear regression model, right? We have cross entropy to do categorical target models to measure them. So here we have all those things. We'll show you how to do these things. Okay. So of course there are some other things we will cover in a later course. So first is the data. Okay. We like to analyze data, right? So the very first things I would like to introduce is this one, file. So you simply just click it and drag it to here. Okay, that is a file. Okay, the name is file. Okay, and the right hand side there are certain dots right here, right? Certain dots right here. That means this widget 啊，就是这个小的这个组件哈 ，this widget can connect to other widget at the right hand side. So there is a small dot at the right hand side. Okay, if you put your mouse, okay, and stop right here, it says, okay, this widget is a file. So there is no input for this file. So that at the left hand side, there's no dot. But at the right hand side, the output is a data structure called data, and it can output those data to the right hand side. Okay, so let's take a look. Just double click it. Okay, double click it. It says, okay, you can load your data. Okay, there are several different ways. Okay, the first, there are some built-in data. So you can click this value, browse documentations data set. Okay, click it and it will show, okay, there are 1, 2, 3, 4, 5, 6. There are 6 built-in data. Right here, you can use them. Okay, we select this one, iris, which is I think this the most famous data set when you learn data analysis. Okay, iris data set, and you open it. Okay, so you can see that here is the iris.tab. tab means a table. Okay, it is a data format. Okay, used by Orange. However, if you have your own data, you can simply just click this one and say, okay, I would like to open some data. Okay, and you can see that there are several different data formats, including CSV file, which is quite common. Okay, in the later class, we will give you a lot of different data sets for you to analyze. Again, it probably it is formatted as CSV, which means comma separated values. We will show you later. Or if you have some Excel data, which is also good enough, okay, you can import XLS, which is Excel spreadsheet, or the newer one, XLSX, the new Microsoft Excel spreadsheet. Okay, you can use all those things to import your data, which is fine. However, we choose this one. After you choose this one, okay, take a look at this one, this part, okay? It says, okay, this data set has 150 instances. That means you have 150 rows, right? As just we explained, okay, from 1 to n. The n is 150. Okay, how many features you have? We have 4 features. So we have x1, x2, x3, x4. Okay, basically like this. Okay, so here's 1, 2, 3, 4. So we have 4 features. Okay, yeah, its name. Those features are all numeric data. So it writes numeric data. Those are features right here. And how about our y? How about our target? The 5th column, its name is iris, and it is a categorical data. Okay, so its row is target. It's your y. So basically, when you import your data, you can have a lot of features, which is fine, but you can have only one target, because in linear regression, in logistic regression, we have only one target. Okay, if you want to do multiple target problem, we will talk about later. Okay, so the value of this target, okay, is right here. Iris setosa, iris versicolor, iris virginica. So although it is text, 就它是文字, but it's specified. It had 3 different classes. Unlike the logistic regression we did, have only yes, no, 1, 0, borrow, long, non-long, yes, no, win, lose, something like that. It's binary classification. It had 3 different classes, but it is still okay. Okay, it's still okay. However, when you import your data, you say, okay, I don't think the iris is target. You can simply just double click this row. Okay, so you can see it is either a feature or target. Meta means you just ignore it. Skip this, don't load this column to orange. Okay, you just skip this column. Okay, so basically it is a target. So you simply make sure everything is right. Okay, sometimes, okay, if it missed, okay, you simply just click it. Okay, it is either numerical data or it is a categorical data, or it is a text data, or it's a datetime data. We will talk about text data at the end of the semester. Daytime, we seldom use it. Okay, so it is either categorical or numeric. Okay, so we click this. Okay, how do we observe this data? So you go to this one. It's called data table. Okay, data table. You hover your mouse. Okay, it says at the left hand side it can input data. At the right hand side it can output data or selected data. So basically the file can output data. So you can use your mouse to connect these 2 widgets. Because file can output data to the right hand side, and the data table can accept data from the left hand side. So do such kind of connection is okay. So after you pass your data from your file to the orange data table, you can double click this one and see, okay, that's the current table. Okay, so similar to what I draw in my iPad. Okay, number 1, 2, 3, 4, 5. So there's about 150 data set, right? So the white ones, white columns, those columns are features. So there are a lot of numeric data right here. And at the last column, which is the gray background color, okay, that is the target. Okay, the name is iris. So there are 3 different, you can see that is iris setosa. So the first class, the second class is iris versicolor. The last one is here iris virginica. So we have 3 different types. Okay, you can just close this table. So you have your table prepared. So what is next? The next thing is I'd like to do some data manipulation. So there are two different things right here. It's quite important. That this one and this one. Here we have a hands right here, point to certain row. The hands, the finger point to a certain column. So that is select columns or select rows. So if some data, which means certain rows, or some features, which means certain columns, is not what you like, you don't want to use them to participate in your analysis, you can simply say, okay, I want to put it right here. The select rows, okay, it can accept data from the left-hand side and output the matched data, unmatched data, or the entire data. So if in this data table, I only want to select, for example, versicolor and virginica, something like that. If I would like to delete the setosa classes, okay, what should I do? So I connected this to this one, okay, and you can see that this line becomes dotted line. That means data does not pass from the left hand side to the right hand side. So you simply click this one. Okay, you say, okay, at the left hand side, I want to pass data to the right hand side. Data, you connect these things. So it will become solid line. So the data pass to the right hand side. So in the select row, what should we do? Okay, you can see that there are several things can be done. For example, if I only want to select certain rows, okay, so I can add condition right here. So it has several. It has several several menus. You can see. Okay, for this iris class, I only want data is either virginica or versicolor. I don't want data of setosa to be passed to the right hand side. So you can select it like this. So in this case, look at this one. Look at it here. The input data has 150 rows. And after you pass this condition filter, at the right hand side, there will be only 100 data. Okay? So in the meantime, you can still connect a data table right here and see, okay? And this is, okay, only the matched data, the data which match the condition will be passed to the right hand side. So you click this and you can see, okay, there are only 100 data right here. Right? Only 100 data right here. And all of them are either versicolor or virginica. So we simply just filter out setosa, the data which belongs to setosa, so that you can easily just do such kind of filtering. Okay, that is how you select rows. It is the same as select columns. Okay, so you simply just connect it to here, or if it's a dot line, so you click it. Okay, I want to connect the data to data. Double click the select column. Okay, it says, okay, since we have 5 columns, right? 4 features and 1 target. Okay, if I would like to drop one of the column, so we say, okay, I don't want this column, so we simply click it to here. Only the features and the target values. Okay, I don't want this metadata, so I put it at the left hand side. I only need these 3 features and this 1 target. So if you connect it right here and you connect it here, it says okay. So you can see that there are only 3 columns right here, and here is the target. So by using the selected column and select rows, you can select the column and rows you want. Okay, sometimes your data is not clean enough and you want to do such kind of things. Okay, so just in case you need all the things. Okay, that is data. Okay, so next things, I would like to visualize those data. All those other which we will introduce in later classes. Okay, visualize. I think visualize is quite important. The first thing is scatter plot. Scatter plot， 它的中文应该叫做散布图啊，散布图。It's quite straightforward. Connect your data to the scatter plot and change it to from data to data. Okay, you simply just connect it. Okay, data to data. Double click this one and you see. Okay. Since we already assigned what is target, so here we have a color right here. We use the class, iris class, to represent the color. So at the left hand side, you see, if it is setosa, if this data is setosa, it is blue color, it is versi color, red color, it is virginica, then we paint it in green color. So, however, it is a 2D surface， 就是它是一个对吗？两个 dimension 的嘛，2D 的一个图嘛。So you have to select right here. What is the X and Y? X the X and Y you want to use. So since we have 4 different features, so you can randomly select whatever you want. You can observe. You can try to take a look at those data. Okay, and to understand, to know your data. Okay, so in this case, okay, we select 2 random features. The one is petal width, the other is sepal length. Okay, as x-axis and y-axis, and we can see that okay, this data looks quite good because blue points, which is setosa, is quite like a cluster. 就是蓝色点都聚在一起嘛。And the blue ones and the red ones, they looks like they can be partitioned perfectly by using some line. Okay, 就是它们也聚合的蛮好的。So that is so we have questions that can we use some model like linear regression or logistic regression to tell how do we partition those things? Okay, just like the score. Setosa, vertical. Okay, let's take a look at this one. We use do the demonstration. We do this and we connect it right here. I'd like to remove some data. Okay. I'd like to remove the versi color, for example. For example, we only preserve setosa and virginica. Okay, so and then we take a look at this figure to be simplified. Okay, we can see that setosa and virginica, they are partitioned, right? It's simply like, okay, we have some data points, okay, just like the score we used in the NFL example, right? We have to know which one wins and which one loses. Okay, so here we still have 2 class. One class is green class, one class is blue class, right? And here is our data. Our data looks like this. Right, we have different scores, different features right here. We have we have 4 features right here. And for the Y, target Y, okay, it is either setosa or virginica. It's very similar to the logistic regression we use, right? We have a score right at the right hand side, right? Now we put it right here. We have score, right? And our target is win or lose, 1 or 0. So right here it's the same. It's either setosa or virginica, and we have to use the 4 features to do a prediction. It is 0 or 1, setosa or Virginica. Okay, how do we do this? Okay, so let's take a look at this one. So the data table is right here. Okay, so the first things we like to do is we have to select the model. Since we have a binary classification problem, so I think the logistic regression is good enough. So that's right here. Okay, so how do we combine those things? Okay, the upper side, the upper things is about observation and try to let you understand how data looks like. So we just put it right here. Okay, so at the bottom side, we start to analyze this table data. Okay, the first thing you have to do is, since we have this model, so this model need to be measured, need to evaluate. So in evaluation, you have to put test and score right here. The test and score means they will help you to calculate the MSE value or the cross entropy value. It depends on your target. But as we mentioned here, did you notice that our target is categorical data, is either 1 or 0, is either Setosa or Virginica, right? So basically, the test and score, this widget, will automatically use cross entropy to analyze your data and model. If your data is numeric target, the test and score, this widget, will automatically use MSE to evaluate your model. So that's here. Okay, so let's see. Basically, the connection is like this. Okay, so let's take a look at this one. Okay, test and score. At the left hand side, data should be inputted into the left hand side, right? It says data. So basically, we connect this data table to this test and score, and we can double click this one and we connect the data to data. Okay, so that is okay. And again, in additional to data, what else you need to input to the test and score? Okay, did you see that? The third one called learner. Okay, the third one called learner. Actually, the learner in in here is, you can simply just view it as the model. Okay, so it needs a model to test those data, right? So here's the logistic regression. The regression says, okay, at the right hand side, it can output a learner, a model, right? So we simply connected it to here. So basically, to evaluate the model, we need the model itself, which is a learner right here. And to test it, we need data, which is the big table, right? So that is, what do you do? It's done. Okay, so how do we see, since it is a categorical target, how do we evaluate it? Just double click this one. Okay, what it says. Okay, it says this model is called logistic regression, okay, which matches this name right here. Okay, since we would like to see the cross entropy, right? So however, there are several things we need to discuss right here. There are several settings right here at the left hand side. Okay, we have several different radio buttons right here. You can only select one of them at one time. Okay, the first concept we like to use is cross validation. What is cross validation means? Okay, as we mentioned in the second week, okay, we have a bunch of data. Okay, a bunch of data is right here, right? A bunch of data right here, and we want to use those data as the training data to help us to find the optimized parameters, theta star or A star, B star, as we mentioned before. Okay, but we can prepare another set data called testing data, right? Testing data. So after we have all those data, all those model prepared, we input new test data into those model. And those model will give us the prediction, right? But actually for those testing data, we have the actual target value, the ground truth value 就是真实的答案呢，真实的 y. So we can compare, okay, what is the y hat value, which is the value given by the model, and what is the ground truth value, which is given by the testing data. We see, okay, are they similar? Are they good enough? What is the MSE value of between them? So that is. So how do we do the test using test data? Unfortunately, most of the time we have only one data set. 就是大部分的时候我们不会有两个资料集啦，就是一个 training data 一个 testing data. So one of the best ways to do cross validation. The number 10 right here, it means you divide those data, the only data you have, into 10 different parts. And you use 9 parts to do training, to make your model, to find your optimized parameters. And use one part data to do data testing. Okay? So there are several different numbers right here. So 5 means you divide your data into 5 different parts. You use 4 parts to find your optimized parameters and use 1 part to do the testing. Okay? So on and so forth, so on and so forth. 2 means you use half your data as training data, use another half as testing data. Okay? So here is, and usually we use 10. Okay, usually we use 10. Okay, that's one of the way. Okay, or you can use this one, random sampling. Okay, you can use any number right here. You can 60% of data for training, 40% for testing, 90% for training. You can use any one of them. Okay, and of course you can repeat this 10 times, and you calculate an average number of your testing. Okay. Or you can, right here, test on test data. You can input 2 different data sets, one for testing, the other set for training. Okay? And usually, but I said unfortunately, usually we have only one data set, so we use cross validation quite often. Okay, and we use the word 10-fold cross validation, or we'll say 5-fold cross validation. Well, usually we use 10-fold cross validation. Okay, so that is it's good enough. Okay, so after the test, okay, we can see that there is a confusion matrix right here. So we put it right here and connect it at the end of the test and score. It says the evaluation result will be passed to the right hand side. And what is confusion matrix? You double click it. Okay, you see that we have a model right here. Is the logistic regression. The logistic regression will draw a Z-shaped line. Okay, try to use the 4 features of the iris data set to predict it wins or lose. It is 1 or 0. It is iris virginica, or it is iris. The other one is setosa. The other one is setosa. Okay, so you can do this. Okay, so it says logistic regression. Okay, after do this 100 data sample, the upper side is the predict. The left hand side is the actual. So the predict is y hat. The actual is y. Yeah, it's y. Okay. I would like to do this. Okay. So this is our data table. So this. Okay. That means, okay, I have 50 instances, 50 rows. Okay. The actual y is setosa, and the logistic regression can magically predict its y hat as setosa as well. So the purple one, this 50 instance, they are correctly predicted, right? So the other 50 ones, okay, the actual Y is Virginica, and our model, logistic regression, by using the 4 features and the Z shape, they can correctly predict, okay, it is Virginica, so that is 50. So the accuracy is 100% because it does not have any misclassification. Okay, sometimes you can simply add a data table, okay, right after the confusion matrix. Okay, so you connect the data to data. So data to data, you can view that. Okay, the very first sample, okay, there are 4 features right here, and logistic regression is right here. It can successfully classify this instance by using the 4 features right here to setosa. So that is the Y hat, and here is the actual Y, so that is setosa. So that is correctly classification. So of course, that is because from the scatter plot we can see that these 2 data sets is quite separated. So you don't mix any data here, right? However, if we do this, sorry, not this one. If we put all the 3 classes into one data set, okay, you can see that there are some points, okay, the red point and the green point, they are somehow overlapped. So maybe for this data set, okay, logistic regression is not that good enough. So let's take a look at this one. Okay, we put the things all back to here, and we see right here, and we can see that for setosa, okay, by using the 4 features, okay, to correctly classify, okay, the predict means Y hat, okay, the Y hat and Y are the same. However, only 47 versicolor will be correctly classified to versicolor, right? There are 3 instances which is Y is versicolor. However, our logistic regression model says no. I believe these 3 instances, they belongs to Virginica, which their Y hat is Virginica. But however, actually we know it is versicolor. So the red one, these 3 data point, they are misclassified, 就是分错了, okay? And the same, these 2 instances, okay, which should be Virginica, but our Y hat, our model says it's versicolor. So there are 2 instances which is misclassified. So let's go back to this score and test, and we can see that the CA stands for accuracy. The accuracy is not 100% anymore. It's only 0.67% of accuracy that the model can correctly classify the data into the corresponding correct classes. Okay, we will talk about all the things later. Okay, they just a very simple. So basically, this structure. Okay, you import data, import the file. You take a look at this data. You select the rows and the columns you like. You draw a scatter plot. Make sure you understand what is the visualization of your data. And then here's the data you want to analyze. you connect it to a test and score. The test also will use an SE or cross entropy automatically. Okay, and you connect a model right here, then you can see the result. And in the meantime, there are several different models right here, right? So basically, okay, even if you don't know how those algorithm works, which we will teach you later, okay? But for example, SVN, you can simply just put it right here and connect it again to here, okay? Or you can use, for example, right here, connect it right here. That means I would like to use different models, but use the same data set. I want to do a comparison of this score. And you can simply just click it and it will show you, okay, which one is best? It says, Logistic Regression has best classification accuracy, which is 96.7%. It can accurately, correctly do the classification. If you want to see the detail, okay, click the confusion metric. It says, okay, for logistic regression, the classification result will be like this. For another model, SVN, the classification will be like this. For tree model, the classification will be like this. Okay, if you need any detailed things, you can just take a look at this table. Okay, or for logistic regression, what is the things we know the underlying mathematical theory behind the logistic regression. So basically, we would like to know the optimized theta, right? So if you want to see where is the optimized value, you can simply just click connect a data table at the right hand side of your model. Okay, it says what it says. It says coefficients to data. However, this data is dotted, right? Because when you want to see the coefficients, you need to connect your data to your model. And here is the coefficient. So it says that is the coefficient. Right? So if you want to do the classification, okay, the coefficient of these features is right here, and here is the intersection. Okay, so that is how you get this theta star. I'll get this theta star by using this method. We will talk about this tool every time when we finish either one of the algorithm. Okay, to make sure you know the underlying background of those mathematical things, those theories, and how to calculate those algorithms. And also, we'll show you how to use the orange to analyze the data by using this new algorithm you learned. Okay, so let's stop right here. Okay, I think that's all. Okay.